What is up, Glenwood? Welcome to the first ever Where and When in the World is Mr. Cartwright. So Mr. Cartwright will be traveling through time and space to bring you the most relevant math stories of our history. Let me step into our time machine for our first destination. I don't know if that worked or not. Cool, so here we are at the birthplace of mathematics. Welcome to this luscious, beautiful rolling hills where the very first measuring device was invented over 37,000 years ago. Not long after, only 17,000 years, we had our first calendar that was engraved on the leg bone of an animal. This was later followed by the first instances of algebra and geometry, all located in this country. You get bonus points for 1, naming the continent, and 2, naming the country that I am talking about, the birthplace of mathematics. The first place these events were ever performed on the world was right here. So, stay tuned after the lesson video for a preview of coming attractions, who won the Done contest, and you guys have a wonderful week. Take it away, Mr. Cartwright.
What is up, Glenwood? I just ran here from wherever that country and continent was, and that will be displayed for you at the end of this video. So congratulations to my 9th grade class. We, at the end of the week, will have successfully completed Module 1. It is done. Done ski, dead forever. You never have to learn anything that was from Module 1 in Module 2. Just kidding, they're almost identical. So, to get started with Module number 2, right? Remember, we have a test on Module 1 this week, but please don't worry. If you don't do well on it, you're welcome to retake it as many times as you like. Just remember, the questions and the answers will be slightly different each time you do. Yes, test Friday, standardized test on Tuesday, but Module 2 is what we are starting today because we are done with Module 1. Congratulations. They said this online learning thing couldn't be done, but man, we did it, kind of. We did a module, and actually you guys seem to have understood it better than my previous class, so congratulations. I'm proud of you guys. We have 2 new vocabulary words to talk about today, and they have to do with our new types of equations that we're going to be learning about. So, to get started, we now have a discrete equation and a continuous equation. And a discrete equation is like quantitative, right? It comes in small little packets of numbers, right? It's not a complete smooth graph. And continuous is just the opposite, right? There is no stop in a continuous equation. And it's the equations that we've been talking about this whole time, right? Is one that has a line. A discrete equation, however, looks a little different. And it looks like a piecewise function, which is one of these guys, right? So this is called a piecewise function, right? And that's because it comes in little pieces, right? So a discrete equation is piecewise, and it comes in little pieces. And it looks like this. It's got a circle on one side and an open circle, or an O, on the other side, right? The closed circle means that that point right there is included in our line. However, this point over here, the circle, is not included in the line. So what is included is the next closed circle. So a piecewise function has all of these numbers in it, and then it goes up to the next value. What that means in this instance is that the y value can only be this number, right? Let's say that is 1. Y is 1 for all of the x values in between here and here. Once it hits here, it jumps up to the next value of y, okay? So a piecewise function, or a discrete function, has little chunks, and you can go in either direction, right? You could have a circle that is closed on this end and open on that end. However, that would not be a function. Through the vertical line test. You guys all remember that? Real quick review, vertical line test. To determine whether something is function, you pass a vertical line through the function. So, will it function? Yes, it does, right? Will it function? No, it won't, because you can see right here there are 2 points where the C crosses the line, right? The other 2 words that we've started learning is linear versus exponential. And an exponential has an increasing or a decreasing rate of change. So it looks like a logarithmic graph. And a linear goes up at a constant rate, right? We know linears to be arithmetics. So we got linears are arithmetic, exponentials are geometric, linears have the equation y equals dx plus a. Exponentials are pirates, right? They have yar math. Y equals AR to the x power. What else to say about linears and exponentials? The green actually came out surprisingly well. We're probably going to switch over to green. I don't like yellow. Moving on, we have one kind of example question from our previous unit. We have a 1,500-gallon pool that is draining at 3% per minute. Let's go per minute, right? So we have a 1,500-gallon pool draining at 3% per minute. How long does it take for the pool to drain entirely? So we can either look at this 2 equations. Well, first we have to set up our equation. We're going to recognize that this is a common ratio, not a common difference. So our ratio is not 3%, right? Because if we take 3% away, how much do we have left? Very good. We have 97% left. So our ratio is 97%, which as a decimal is 0.97. So when we're plugging that into our pirate equation, we have y equals a times 0.97 raised to the x power. Okay. Our starting point in this case, 1,500-gallon pool, is what it is at time 0, right? At 1 minute, we've already drained 3%. So at time 0, we can plug in our a value and we get y equals 1,500 times 0.97 x. And one thing we can tell you right off the bat is that this question that I originally posed is not an accurate one, right? If it's draining at 3% and it's mathematically accurate, would we ever actually have an empty pool? No, we keep getting closer and closer and closer. The total amount would be going down by 3% every time, but 3% of 1 is 0.97, and then 3% of 0.97. What we have here is a decaying graph, but it'll never actually reach 0. It'll get really, really close, but the limit is 0. So it will never actually reach 0. So the question we posed originally is moot. However, given this equation, we could find whatever time we wanted to, right? If we picked infinity, we would get close to 0. All right. Thank you so much for watching. Back to Mr. Cartwright for the answers to our previous question and the winner of the dunk contest. See you guys soon.
Thank you so much for playing, Glenwood. That was Eswatini. Congratulations for anyone who guessed Eswatini on the continent of Africa, formerly Swaziland. The first place mathematics has ever been proven to be done on this planet Earth due to carbon dating. Congratulations to Mr. Cartwright. That's me. I am the winner of the dunk contest as voted on by you guys. Thank you very much. And finally, preview of coming attractions. So this week we have a celebrity guest on Friday. This person I will be extending a challenge to that we will complete in the following week. I am super excited to take on one of the greatest generational talents of our time in a contest that you guys will find out about on Friday. Thursday has another Mr. Cartwright original, and you guys have a wonderful week. Please return to the live classroom.